Today we will talk about change in the value of a quantity or a variable. Let's start with x represented on this line. Let's say initially the value of x is x1 and after some time it changes to x2. Then we can clearly see the change in x is this much. We have a special representation for change and is represented by delta over x, which is x2 final value of x minus initial value of x, x2 minus x1. Let's try to understand how this change will evolve with given values of x1 and x2. Let's suppose in this table, the first column represents x1, the second column represents x2, and the third column represents change in x, which is nothing but x2 minus x1. Let's say x1 initially is 99 and x2 is 100. Then we can clearly see the change in x, delta x here, is just 1. If the value of x1 is 99.99, let's say, and x2 is 100, then you can see the change will be even smaller and would be like 0.01. Let's suppose x1 is 99.9999, then the difference will be smaller, but it's still measurable. But let's say somebody says, let's say x1 is 99.99 and a very large number of 9 here and then a 9. We can see this value of x1 is very close to x2. So close that we can't measure the change, but obviously we can notice a change. Such type of change cannot be measured. What can be said about that change is the change will be very, very small. So if a change is measurable, then in general they are represented by delta x. So these changes here are measurable or finite change and is represented by delta of x. So delta x not only represents change, but it represents a finite change. But changes like this, which are very small, let's say they are infinitesimal change, they are represented by d of x. So we must note the representation. Delta x is a finite change, dx is infinitesimally small change.